Okay, I'm going to go through some examples of different pollutants that pollute surface water. This definitely is not an exhaustive list of all the examples, but it's a good start. The first one is oil, and oil is usually going to be polluting the oceans, and it's usually going to be by accident. Sometimes it's on purpose, and that's usually through military activity. So when it happens on accident, it is bad because it coats animals with oil, and it kills plants and essentially destroys that ecosystem. It takes a long time, many tens of years, for it to rebound. In 1989, the Exxon Valdez tanker ran aground off the coast of Alaska, about 40 kilometers, and 11 million gallons of oil spilled and then washed ashore. It really had a big effect on the aquatic birds, shorebirds, as well as marine mammals. So it was a big wake-up call that we have to be way more careful with our tankers. There are a lot of things that went into why that happened and then why they weren't prepared to deal with the aftermath of it, but it changed a lot of rules, and that turned out to be a good thing. In the Gulf of Mexico in 2010, there was the drilling platform that had the blowout, and they couldn't contain the oil that was being pumped into the Gulf of Mexico. That was a big thing on the news, and it was going to wash around the oceans and kill all of marine organisms. But they did finally get it contained, and they're still doing research about pockets of oil that are still found on the seafloor around the Gulf of Mexico. The next one we're going to look at is this. So notice the pristine stream on the left, and then here's a stream coming in on the right. The tributary coming in on the right is muddy. That's soil that has been picked up somewhere and eroded and moved and is now going to be polluting this stream. So that's sediment as pollution. It depletes the soil, so there's a loss of soil as a resource at the spot where the erosion took place. It's going to reduce the water quality by increasing the turbidity. Turbidity is a term in this case that means suspended solids in the water. That's giving it that milky look. Fish, they breathe through their gills. And so they're going to be sucking in that sediment in their gills as they're trying to extract the oxygen. Now they've got dirt in their gills. This kind of mud also kills corals. If these rivers are near coastlines, it washes on top of corals, that sediment, and basically smothers them. Usually the sediment is fine grained that it's moving because it doesn't take as much energy to move that fine grained sediment. It's silts and clay, so it's really small. It's part of the suspended load. It can move a really long ways. Oftentimes it's runoff from agriculture or construction or logging. What do those have in common? Agriculture, construction, logging. Give you a second to think about that. Well, what they have in common is that they all involve exposing the soil to erosion and rain and the removal of vegetation, right? When that happens, there's usually a shift in the equilibrium of a stream. So there's going to be sediment pumping into the stream that can change the gradient of the stream. Changing the gradient can change the erosive power of that stream. It can cause erosion in places that were not really anticipated and deposition in other places where it was not anticipated. This example here on the right is livestock trampling the stream banks. We see that all around Watauga County. All right, what is this? These are cooling towers, right? So what's coming out of the top of these towers is steam. And that is thermal pollution if it were to go back into the stream. So what happens is, in line with a stream, they'll pull off some of that discharge and they'll send it through, this usually an electric power plant. Everything's getting hot in there. They'll send that water through the system and then perhaps pump it right back into the surface water. If that goes right back into the surface water, the temperature is going to be elevated because they've used it to pull off that heat. When that temperature is elevated, it can have a negative effect on cold water aquatic species, right? Mussels or fish like trout who thrive in colder waters. Heating that water will make them not thrive. So one way to eliminate this problem is to take that hot water that you've used to cool off whatever industrial process you have going on and send it through radiators and maybe use it to heat buildings, things like that. So there are ways around thermal pollution. Nutrients. This is a big one. We've talked about it before with the importance of wetlands. And this is adding in essentially fertilizer into surface water. So this image here, all different fertilizers, and this is just one corner of a Lowe's home improvement, right? You can find lots and lots of fertilizers to put on your lawn, in your garden. Nutrients can come from, here's another example, from a sewage treatment plant. Sewage, manure, any of those are vitamins for the plants, and so that gets into the water, then it's going to cause something called cultural eutrophication. Cultural eutrophication means well-fed, and well-fed means you're going to have a rapid increase in plants and algae mostly. So on the right here's some gooey algae. I used to love to play with this stuff as a kid. It looked like hair. In ponds, it'll cover up the whole top of a pond and block sunlight. When that happens, these plants, there's a bloom of them, they're going to die. And when they die, their decomposition by bacteria is going to cause a drop in dissolved oxygen. BOD there is biological oxygen demand. There's some pigs. So here's biological oxygen demand. It's oxygen demanding waste. This is dead organic matter. Those dead plants, sewage, algae, the bacteria that's decomposing them is using up oxygen. So now the water supply becomes depleted in oxygen. It's too low for organisms that extract oxygen from the water, like we mentioned, fish and their gills. They basically are going to suffocate at this time. Okay, we can measure it. There's a meter for that, and it's called a DO meter, and it measures the amount of dissolved oxygen in the water. When that dissolved oxygen level is low, we say that there's poor surface water quality, poor stream quality. BOD is the biological oxygen demand. When that is high, then the stream quality, water quality is low. The oxygen demand is measured as milligrams per liter of oxygen consumed over 5 days at 20 degrees Celsius. So high BOD means there's lots of dead organic matter, so there's lots of oxygen being consumed over 5 days at 20 degrees Celsius. So a high BOD is going to be coinciding with a low DO. High biological oxygen demand goes along with low dissolved oxygen. The Neuse River gets this often, that flows through Raleigh and then down east. They spread manure, usually pig manure, because North Carolina grows a lot of bacon. They'll spread that pig manure on the fields, and then it'll rain, and then that manure washes into the Neuse River. And then we have this situation set up where the dissolved oxygen goes down and there's a big fish die off. Ooh, what are these? These are pathogens. Pathogenic organisms. These cause diseases. So these are tiny little organisms. This is what you get if you're hiking along Blue Ridge Parkway, you decide to bend down and drink some of that nice cool water, and you gulp some waterborne disease-causing organisms. Usually that would be something like E. coli if you're just drinking out of a stream. So some examples are cholera, that's a bacterial infection. Typhoid is bacterial. Hepatitis is a virus. Dysentery is a bacteria. All those sound scary and things like you do not want to have. When we test water, surface water, for these organisms, what usually is the test is human fecal coliform bacteria, because what's degrading the water supply is typically going to be sewage. Sewage from humans, sewage from cows is going to get into the water and cause diseases if you drink it. So it's E. coli is in all, right, the human fecal coliform bacteria, it's in all human waste. Your poop just has it. And so it's a good standard measurement for water quality. The presence of that fecal coliform bacteria signals that the water quality has been compromised. Not all fecal coliform is safe and not all of it's pathogenic. The one that's not good is the E. coli. So that's what you do not want to ingest. It's safe coming out of your gut, but it's not safe if you eat it. In the US, this problem is mostly eradicated. We do a pretty good job of separating our sewage from our drinking water, but worldwide it's still an issue. If you click this link, the World Health Organization is a fantastic organization that monitors the world's health and diseases and the health of the water supplies. Oftentimes, the outbreaks of these different E. coli, Cryptosporidium, Giardia, cholera are going to coincide with a natural disaster. In a natural disaster, people maybe have had to move out of their homes. They're drinking compromised water. The sewage treatment has been compromised because of the natural disaster. Anything from earthquakes, floods, hurricanes, tsunamis, where the water supply and the sewage system is damaged at the same time. All right, toxic substances. This is kind of a blanket term for any kind of hazardous chemicals that could get into the water supply. This is things that are bad for organisms. Any synthetic, organic, or inorganic compounds that decrease the health of organisms. Some examples of those would be like heavy metals or radioactive minerals. Both of those sound bad, right? So heavy metals, examples of those would be things like lead, mercury, zinc, arsenic, cadmium. And those probably ring a bell to you as things that are not safe for you to consume in certain quantities, right? Some of it that is, there's always some of that in the environment. You're always eating a little bit of this, a little bit of that, like zinc, that sometimes found in vitamins. So, but you don't want to ingest lots of lead, mercury, arsenic, or cadmium. They're oftentimes washed from tailings piles. This is the leftover piles of rock that is not, say, the ore that you were looking for. It's what you didn't want to mine, like the overburden, that pile of rocks left over from extracting what was the needful thing. Found in industrial waste, landfills, released when processing ores. Arsenic is one of those toxic substances that is found in coal ash ponds. So we've had some big coal ash spills around North Carolina and Tennessee in the last 5 to 10 years, and arsenic is found in those coal ash ponds and gets washed into our streams. When those get washed into streams, they are deposited with the sediment. So the sediment in the stream channel is going to have these different heavy metals in them. We call this a placer deposit. It's kind of a deposit kind of sorted out by the weight of those different minerals. This would be like if you're painting for gold, you would look for a placer deposit, a place where heavy metals accumulate. If they do get deposited on the floodplain, though, these heavy metals can be taken up by plants like crops and then taken in by animals. And those animals, humans included, would have neurological disorders. This is true for arsenic around Blowing Rock and the apple trees. If you don't know, there are apple orchards, old ones, around Blowing Rock, Moses Cone, Bass Lake, and those apple trees have been pulling up arsenic for many years. So don't eat the apples in Blowing Rock because of the arsenic in the apple trees in the soil. It also bioaccumulates. What that means is, say those heavy metals are in the water and a bug, a caddisfly larva, eats that sediment. And so now the caddisfly larvae, all of them, let's say there's 100 of them, all eat the sediment. They have some heavy metal in them. And then a trout comes along. A trout eats caddisfly larvae. So a trout might eat all 100 of those. So now the trout has all the metal from 100 caddisflies, right? So it's accumulating in that trout. It's going to sit there until a bear comes along, and the bear is going to eat that trout. And the bear might eat 20 trout that all have the heavy metal from 100 caddisflies. So now you've got thousands of bits of lead in that bear from the caddisflies from the trout. What you don't want to eat is a bear. Bears, that's not funny, are at the top of the food chain, right? So the organisms at the top of the food chain, bears, sharks, mackerel, tigers, those are all going to have more heavy metals in them than other organisms. And humans are at the top of the food chain, right? We can eat whatever we want. You do not want to eat anything at the top of the food chain if you can stand it. Okay, in humans it causes heart disorders, cancers, neurological disorders as well, right? We all, kids get tested for lead exposure at an early age because it can really affect your brain. Radioactive minerals are found naturally in rocks. Granite and shell have radioactive atoms in them, and if they decay, they can accumulate in water. You may have heard of radon in your basement. They can get into groundwater. It can cause cancer in humans. Acid mine drainage. These are examples of acid mine drainage, that red, rusty color that's coming out of a mine. And here's the equation for that. You take FeS2, that is the mineral pyrite, in the presence of oxygen in water, and it's going to rust or oxidize and give you Fe2O3, which is a hematite. The other byproduct of that reaction is sulfuric acid. That is acid mine drainage. It's acidic water that drains from a mine, primarily sulfuric acid, and it comes from that weathering process where we're weathering sulfide-rich minerals. And let's see, there's the equation again. It pollutes surface and groundwater, so it gets into the surface waters, and then it also can become polluted groundwater. This acid is not good for aquatic plants and animals, and there's significant amount of this pollution in all the states listed here. There are big attempts being made to contain water flowing through tailings piles and to isolate the pollution and to keep it away from water sources. This is really hard to do for groundwater when you have these pyrites exposed and sulfide minerals exposed and exposed to oxygen and also water. So we're trying always to clean those up.